এটা একটা একদম বেসিক সার্ভো কন্ট্রোলার, বেসিক্যালি একদম বেসিক। এখানে একটা potentiometer আছে. If I rotate this potentiometer clockwise or anti-clockwise, the angle of the servo will change. How this works is, this potentiometer has got two leads. So one lead for 3.3 volt input and the other one is ground, and the middle one is the wiper. The wiper is with a variable resistance. So this is actually a voltage divider. So between 3.3 and 0 volt I can get out any voltage. I can get any voltage by rotating this trim of the pot. Now what happens is, this 3.3 volt and ground are connected, but this middle wire, the wiper pin is connected to an analog read pin in the ESP32, and the analog read pin of the ESP32 reads the voltage and it changes the voltage, or it scales it to a digital value. It uses a ADAC converter, analog to digital converter, inbuilt within the ESP, which gives a voltage range. The voltage range is 0 to 3.3, and it scales the value to 0 to 4095. It's a 12 bit, so 2 to the power 12 comes out to be 4096 minus 1, 4095. So for 0 it gives 0, for 3.3 volt, that is max, it gives out 4095 value, and that value I have mapped it to 0 to 180 degree using the map function, and that after that mapping I am directly writing it to the servo.write. This is the method. This is actually very easy one. What I'll say is, you can see the main code. This is the real read smooth ADC. This is the method that I defined for smoothness in the DC, but you can totally skip this. I'll attach the code. My pot pin or input pin is 34th. The servo pin or the output PWM signal pin is 18th pin. I think all of the GPIO pins are PWM pins, so it doesn't matter which one you're using. The ADAC max value, you can see 4095, because 2 to the power 12. Val and angle are two integers. I am communicating serially because of this, so that I can see what's happening actually. You can see I'm rotating anti-clockwise. Resistance decreasing, voltage increasing. Rotating clockwise, resistance increasing, voltage decreasing, ADC value decreasing, angle decreasing, servo angles decreasing. Okay, so this is the thing. It's quite simple actually. I'll attach the code. Int read smooth ADC. This is taking the analog input like 10 times in 200 microseconds of bursts, and I'm returning the sum by 10, so I can get a precise one. This is I'm taking the value, and in the angle I am mapping the value between 0 and ADC max to 0 to 180 degree, and I am writing in my servo and I'm printing the angle, and the delay is 50. You can see here the servo angle will change. And I am powering the servo. The servo is being powered by a buck converter. The buck converter is taking 12 volt input from a geo adapter that I hot wired, and it gives an output of, I measured it. It gives an output of 6 volt. I set it to 6 volt by setting that trim pot. Now this is connected to a 6 volt output. This is not connected to the ESP32. It will burn out the ESP, because this will at max draw a current of 600 amps to 800 amps. 800 milliamps. So 800 milliamps of current through the GPIO pin, and it's also at 3.3 volts, so it won't be fully powered on. So I'm using this one. Even you can see, if I am increasing this potentiometer pot very fast, the light will dim. See, because current, huge spike of current, and in huge spike of current the voltage drop will be huge. That's why I have thought of implementing a capacitor at the end of the output. But what I'm thinking is, if I apply a capacitor at the end of the output, and when I'll switch off the capacitor or switch off the circuit, there will be a backflow of current because the capacitor is stored. That's why I'll use a diode as well. See, the brightness of the LED is fluctuating when I am very rigorously rotating the trim pot. This because of this little servo is drawing too much power from the circuit.